Welcome to section 4.6, the quadratic formula and the discriminant. Now, before we do any kind of example, any work when dealing with the quadratic formula, there's some basics we need to cover first, which is simplifying radicals. The reason is we're working on simplifying radicals is sometimes we may not have perfect square numbers. So, to be more specific, when it comes to simplifying radical, we're going to focus on the square root. Because when coming with the quadratic formula, the only thing it has is the square root. The reason I mention about that is because there's actually different type of roots, different type of radicals. There's the third root or the cube root, the fourth root, the fifth root, the sixth root, the seventh root, and so on. But when it comes to quadratic equations, quadratic formula, we're dealing with square root, or to the second power. Now on the side where I wrote here, I wrote the perfect square number, so 2 squared equals to 4, 3 squared equals to 9, 6 squared equals to 36, 9 squared equals to 81. The reason I wrote that out is because the ones that underline in red are the numbers that we're going to focus on, are the numbers that we're going to use to simplify radicals. Now let's start off with some basic examples. So say that you have the square root of 16. So when I say the square root of 16, this is what I mean, or what it looked like. So what you're going to do is find 16, alright, and then the square root will be the base number, which is 4. So when I'm doing the square root, I'm just writing out the base, which is 4. I didn't write that 2. So make sure you remember that. Again, I look at my perfect square numbers, the ones that I underline in red. So I repeat, the one I underline or perfect square number. When I'm doing the square root, I'm just finding the base. So my 16, since I'm doing the square root, my base is 4. And I did not include the exponent. So again, the big numbers, 2, 3, 4, 5, 6, 7, 8, 9, 10, are called base, B-A-S-E. The little 2 is just the exponent. Now let's do another example. So if I ask you to do the square root of 4, I look at my perfect square number 4 and the base is 2, so I'm just going to write 2. And then let's do another example, 25. The square root of 25, I'm looking for it, my base is 5, so I'm going to just write 5. Now let's do one more example. It's the square root of 36. Find my perfect square number, 36. My base is 6. So if I ask you to do the square root of 16, you should just say 4. When you're simplifying, this is for simplifying. If I ask you to simplify square root of 4, just write 2 or tell me 2. If I ask you to simplify the square root of 25, you just write 5 or say 5. If I ask you to simplify the square root of 36, you just write 6 or say 6. That's all you have to do. Again, in my past experience, I had students that start off correctly and should just end with the whole number. So here you just stop. I don't know why, but they choose to keep going. What they do, and I would not recommend you to do this, they put another square root over the 4, the square root over the 2, the square root over the 5, or the square root over 6, when I did not ask for that. So if I just say simplify the square root of 16, just stop at the 4. If I ask you to simplify the square root of 36, just stop at the 6. That's all it is. Now, there's going to be some example where you might have to do a lot of work and it look like you have to keep going, but you just gotta be very careful with the work. Alright, now here's the basics with simplifying the perfect square numbers. There's another part we will go over, which is when it's two numbers multiplying inside the radical or inside the square root. So if you have an example, I'm going to use variable a and b to represent numbers, where a and b can be any number. Now, AB, or the square root of AB, can be rewritten as the square root of A times B. Just like this. And notice how I'm making a little mark right here at the end of the square root saying that the B is inside the square root. So you'll see me writing my radicals like this, saying that the B is inside the square root. There have been multiple times where people don't write that little corner to say that this is where the square root ends or this is where the radical ends, and my B is part of the inside. Now, I had students practice this to realize that, okay, the B is inside the radical, inside the root, not outside. When students leave the B outside by accident, then they're actually missing a step, and therefore they're going to mess up their work and get the wrong answer. So be mindful of how the radicals look like. So when I make a little corner here, I'm saying that the B is inside the radical. Now when it's the square root of A times B, you can rewrite it as like this. The square root of A times the square root of B. So if it's multiplying, you can actually split it up. And this is what you're going to be doing when simplifying radicals. Now, this you can only do if it's multiplication or division. If it's addition and subtraction, like this, the square root of A plus B is not the same, does not equal to the square root of A plus the square root of B. That does not work. So for example, if I use my perfect square, 9 plus 100. Again, I'm saying it does not equal to the square root of 9 plus the square root of 100. If I were to add these two numbers, 9 plus 100 would be 109. Again, does not equal to the square root of 9 is 3. The square root of 100 is 10. 109, or should I say, the square root of 109 does not equal to 13. So, if it's adding A plus B, you cannot split. So I repeat, if it's A plus B, inside the square root, inside the cube root, inside the fourth root, the fifth root, and so on, you cannot split it up. The only time you can split it up is if it's multiplication or multiplying between A and B. So make sure you have that little note. When it's addition or subtraction, you cannot split it up. If it's multiplication or division, you can split it up, and it will help you simplify radicals. You will be doing some of these steps, or should I say a lot, when it comes to simplifying radicals. Alright, we have talked about simplifying the basic, the perfect square numbers, and then the basic for when two numbers are multiplying, you can split it up. Next, we're going to focus on simplifying that are non-perfect square numbers.